Hi everyone, welcome to lesson 2-3B where we're going to continue solving multi-step equations. We're going to start off with a little warm-up, so if you can just do this on the side of your paper. Remember from 7th grade where you learned that a proportion is two equal fractions? You proved that. We can see that 2/3 is the same as 8/12 because if we multiply the numerator and denominator by 4, we get 8/12. We could also simplify 8/12 by dividing by 4 and get 2/3. You also learned that with every proportion, the cross products are always equal. So if you multiply going across, 8 times 3 is 24, well then 2 times 12 should also be 24, and this is true for every single proportion. What we're going to do here is just do a quick little warm-up where we're going to solve these three proportions. This will help us to solve some of the equations today in our lesson. Okay, so I've got 4/3 is the same as 8 over what number? Well, if you look here, you can see that there's a relationship going across. So I can see that 8 is twice as big as 4. So then 3, I'd have to make 3 twice as big as well to get x, right? And so here we can see that x would have to equal 6. But what I want you to do is to try doing this with cross products. Even though you've learned this way, let's see if we can get the same answer using cross multiplication. So if I multiply across 8 times 3, I know that that should be 24. So then when I multiply across here, 4 times x would have to equal 24. So then what I did is I just set up a one-step equation. If I divide by 4 here and here, I get x equals 6, which is the same answer you got if you look at the proportion going across. Now here on this one, you guys can see that there's a relationship from 5 to 15. Here, if I take 5 and multiply it by 3, I get 15. So if I do the same thing here, 3 times 3, I would get 9. So the answer is 9. But let's see if we can do this with cross products. So I'm going to multiply across. See, I'm drawing my arrow. I'm going to put the answer right here. 15 times 3 is 45. And then I'm going to draw a line across here. X times 5 is 5x. Just drop down the equal sign and you have a one-step equation. You're just going to solve it like you solve any one-step equation and see how we get the answer is 9, just like that. This is called cross products. So on the last one here, you can see that 7 times 5 is 35. So if I do 2 times 5, I get x equals 10. However, let's see if we can do it with cross multiplication. Here I would write 7x, 7 times x, and then 2 groups of 35 is 70. Drop down the equal sign, divide by 7, and I get x equals 10. See how I got the same exact answer I would have got if I just looked going across, or even if you go up and down. But this cross multiplication will be helpful to us when we're solving our equations today. Okay, now let's take a look at our first example. We're going to see some fractions here. We have 5/18 is equal to how many ninths minus 1/2? I'm going to draw my line down the center here. My goal is to figure out the value of n. So it looks like we're just going to solve this like any other equation. Even if, imagine if I uncovered here or cover this up, n minus 1, I would have to add the 1. So being that's a fraction, minus 1/2, I would just have to add the 1/2. Negative 1/2 plus 1/2. Do the same thing to this side. Bring down the n divided by 9. And here I have 5/18 plus 1/2. I know that when I'm adding fractions, I have to have common denominators. So I'm going to probably just make these 18ths, because we can make a 2 into an 18 by multiplying by 9. So it looks like we end up getting 14/18. At this point, you might see that 14/18 can be simplified, and you absolutely can do that if you notice it. You don't have to, you can wait. So now my goal again is to get the n by itself. I see it's divided by 9, so I'm going to multiply by 9. Same thing over here, multiply by 9. Now simplify before you multiply. These two are divisible by 9. Here I get 2, and then I end up with 14/2. Well, even if I write 14/2 here, you see that that can still be simplified. 14/2 is the same thing as 7. So my answer would be 7, n is 7. So if I plug that back up in here, I can see that 7/9 take away 1/2 is equal to 5/18. All right, we're going to make quite a jump on this next one. Example number 2. Looks like we've got 3x over 4, or 3/4 x, minus x divided by 3, or I could even put a 1 in front of the x and make it 1/3 x. I'm just going to cover up the denominators. What if this just said 3x take away x equals 10? Do you see what to do? Yeah, you'd want to combine like terms. 3x's take away an x would be 2x's, right? So we're going to want to do the same thing. Even though these are fractions, we're still going to want to combine like terms. And sometimes it's more difficult to see that when you have fractions. So in order to combine like terms, in order to combine these two, I have to have common denominators, because essentially I'm subtracting fractions. So I'm going to have to find a common denominator when the denominators are 4 and 3. So it looks like 12. I'd have to multiply this by 3 and this also by 3. I'd have to multiply this by 4 and this one also by 4. That way I can turn them into 12ths. So 3 groups of 3x. Well, that would be 9x over 12. Here I'd have 4x over 12. And that equals 10. So this is where I'm at right now. Now I can combine like terms. I know my denominator is going to be 12. I have 9x's, take away 4x's. Remember, I just subtract the numerators, and that would give me 5x equals 10. Now there's a couple different ways to do this. In fact, I'm going to write it twice. It totally depends however you want to do it. If we were in class together, we would be talking about both strategies. So here, what sometimes kids often see first is they want to get the x by itself. So what they do is they say, well, I'm going to multiply by 12 to get rid of the denominator. And then they say that they want to divide by 5. So they end up doing it in 2 steps. And then they're just going to take 120 and divide it by 5 and get 24 that way. That's one way to do it. But other students can see this happening in 1 step. Here's the x again. Do you see how if you think of this as 5/12 as a fraction, you could multiply by the reciprocal. And same thing on this side, 12/5. The 12 cancels, the 5 cancels, and the x is by itself. Here, you'd have to simplify before you multiply. Divide by 5, divide by 5. 2 times 12 is 24. It's much quicker. It doesn't matter which way you do it. It's just about how your brain thinks about it. You can do it in 2 steps here, or you can do it in 1. But the biggest thing about this one is seeing that if you cover it up, you've got to combine like terms. So to do that, you have to find a common denominator when they're fractions. All right, number 3. Now we're getting really tricky. If you need to pause the video to write this down, go ahead. I'm going to put a line down here so I can organize my work. Very multi-step equation. We got 2/5 being multiplied by the quantity that's inside the parentheses. I bet that your brain is thinking distributive property, isn't it? But think about this. As soon as we distribute 2/5 times x and 2/5 times -4, we're going to end up with 2 more fractions. Then we have a lot of fractions to deal with. Can you think of doing this a different way besides distributing? Let's say that the -4 wasn't there. What if it was just 2/5 x? Would you think about maybe multiplying by the reciprocal? Absolutely. You can do that. This 2/5 is being multiplied by this quantity. You can undo this 2/5 by multiplying by the reciprocal. If I were to multiply by 5/2, do you see how this here is going to turn into 1? And if I take 1 multiplied by this quantity, it's just going to be the quantity x minus 4. Yep, it works. Do the same thing over here. 5/2. Then I end up with 1/2 times 5/2. I can't simplify, but I end up with 5/4. Much easier if you see this, if you see that you can just multiply by the reciprocal. So then I end up with just 1 step left, adding the 4 here. I also have to add the 4 over here, which is the same as 4 over 1. Now, if you have 4 plus 5/4, you'd end up with 4 and 5/4, and you can change that back into a proper fraction. Or you can just find common denominators by multiplying by 4, which would be 5/4 plus 16/4, and then you could add the numerators, which would be 21/4, and you could do it this way as well. Either way, I mean, if you did it the other way, you'd end up with 5 1/4, because 4 and 5/4 is 1 1/4, and then if you add it, so either answer is fine, but you can just leave it improper just like this. Much less complicated than trying to distribute. If you were to distribute, I'm going to show you what would happen. If I distributed this, I end up with 2/5 x minus, and 2/5 times 4/1 is 8/5. And then that equals 1/2. This is what I'd end up with, which isn't a bad thing. It's just that I have the x here attached to the 2/5. I'd have to add 8/5 first to both sides. 2/5 x equals, and then 1/2 plus 8/5. I'd have to find common denominators, and then I could just simplify, I could solve this, by multiplying by the reciprocal. It would work as well. It's just that this is much quicker if you see it. So if I were to continue it, and if you don't want to watch, you can just fast forward the video, but if I continue it, I'd have 1/2 plus 8/5. 10 would be the common denominator, so 5/10 plus 16/10, which would be 21/10 equals 2/5 x. Then I'd have to multiply by the reciprocal, 5/2. Let's hope I get the right answer. Then here I would divide by 5, which is 1, divide by 5, which is 2, and if I multiply across, I get 21/4. The same answer, but you see the amount of work I had to do to get it. This is much quicker if you see that you can just undo this fraction because it's being multiplied by the quantity. You just undo it with the reciprocal. It's going to be a lot easier for you. All right, number 4. Our goal here is to figure out the value of c that makes this true. This fraction is equivalent to 7/2. So what I have going on here is two equal fractions. This fraction is equal to this fraction. They're equivalent. There's a couple different ways that you can do this. One way, some students will see that the 4 is twice as big as the 2. So then they see that this quantity has to be twice as big as the 7. So this quantity right here would have to be 14 because this is twice as big. And knowing that the 3c plus 8 would have to equal 14, they set it up as a small equation right here. Then you can solve for c. So if I take away the 8, 14 take away 8 is 6. And I end up with 3c, then divide by 3, and c is equal to 2. That's one way of solving this. And you're just knowing that these two fractions are equal, so therefore this would have to represent a 14. Okay, that's one way. Now, do you remember in our warm-up today how we were using cross products? Cross products, because these are two equal fractions, will also work. Let me show you that method. I think you're going to like it. These are two equal fractions, and that's why cross products will work. I can multiply across. 7 times 4 is 28. And then when I multiply across this way, I have to take 2 times all of this. So 2 times all of the 3c plus 8. Then bring down the equal sign. Now I just start simplifying. Distributive property here. Bring down the 28. Goal is to get the c by itself, so I take away 16. That's going to give me 12 equals 6c divided by 6. And I get c equals 2, the exact same answer. So two totally different ways to do the problem. You got two equal fractions here, which is a proportion. You could solve it knowing they're equal fractions, just seeing that it's twice as big to get over here, or you could use the cross multiplication method. This next example, number 5, is really easy to see that you've got two equal fractions. You have a proportion. So cross products might be the very first thing that you see that can be done. That's what I see. The goal here is to figure out what number we multiply by 5 here to make this an equal fraction to 8/45. Now, if you think of these as equal fractions here, you may notice that 24 is 3 times as big as 8. So therefore, the 5x has to be 3 times as big as the 45. This is one way to do it. If I use cross products, I could cross multiply. I'm going to need a calculator though, so I'm getting that ready. 24 times 45. My calculator says 1080. Then I take the 8 times 5x. 8 times 5 is 40, 40x. Bring down the equal sign. Now I have a one-step equation. I'm going to solve for x. Divide by 40, divide by 40, x equals, hit divide by 40 in my calculator, 27. Okay, that's cross multiply. I think that's very simple. Now go back over here. If 24 is 3 times as big as 8, then this term here has to be 3 times as big as 45. Well, what does 3 times as big as 45? Let's type it in here. 45 times 3, that's 135. So this would have to be 135. You could pull out the 5x and say it has to be 135 because it's 3 times bigger than 45, and then you could simply just solve the one-step equation and get x is equal to 27. That's one way. Another way that sometimes in class students will do this is they'll multiply both sides by 5x. And there's a lot of different ways, but these are just two. Recognizing that these are two equal fractions, you could solve it with cross multiply, or you could just look at the proportion and see if you can determine how many times bigger the numerators or the denominators are. In number 6, go ahead and jot it down. Again, always a couple ways to do this. Goal is to figure out what n is. Okay. If I cover this up, could you tell me 42 divided by what number is equal to 6? Absolutely. You know 42 divided by 7 is equal to 6. So just starting off here, I know that this quantity has to equal 7 because 42 divided by 7 is 6. So I could pull it out and say 2n minus 3 has to equal 7. And I could solve for n. N is 5. 2 times 5 is 10 minus 3 makes this 7. That's one way to solve this. Another way to solve. Draw the line down the middle here. I could move this quantity to the other side of the equation by multiplying this side by 2n minus 3. If I do that, think 2n minus 3 is over 1. What's going to happen is it's going to cancel here, leaving me a 42. And as soon as I do the same thing to the other side, multiply by 2n minus 3, it's going to move over here. Now remember, I want to take this side 6 and multiply it by the whole 2n minus 3. So I need parentheses. So I'm going to have to distribute over here. So I have 12n minus 18. Now I can continue solving for n. And I get the same answer, n equals 5. I could do that. Okay, one more way. I tried rewriting it again here. I kind of messed up on the 2. Another way you could look at this is I have a fraction here. I could make 6 into a fraction. I could write it over 1. And now that I have 2 equal fractions, I can use the cross multiply method. That's another way. So I'd have 42 times 1 is 42, and 6 times all of this quantity. And then I could continue working it out and solve for n, and I'm still going to get n equals 5. So 3 very different ways of looking at an equation that looks like this. I guess it just depends on who you are and which way you prefer. Thank you for joining me. I hope that you feel like you can solve multi-step equations. Have a great day.